intermediate school, I guess they call it now. We call it junior high in my day. That's the first time I saw it. So what you've got is three components. So sine is equal to opposite over hypotenuse. So SOHCAHTOA kind of sounds like an Indian word. Cosine is equal to adjacent divided by hypotenuse. TOA, tangent, is equal to opposite divided by adjacent. Here's that relationship right here. So really, if you know the Pythagorean theorem and you can memorize SOHCAHTOA, you know everything you need to know on right triangles. You will have access to the cheat sheet. In essence, I don't know that you really need it with a little bit of practice. Pretty easy memorization drill. We'll use this to solve our stuff. Any questions on this? I know this is the first chance you've seen to see this for some of you. First time you might have heard of SOHCAHTOA. Study this on your own. Get familiar with this sheet. Do I care if you memorize SOHCAHTOA? No, I'm not going to ask you to. Are you going to have to use this cheat sheet? Darn tootin' you will. You bet. Okay. Need to know how to use it. Let's put it in practice. I'm going to go to page 35 of your text. Now, when you're reading story problems out of the text, there's a couple terms you're probably going to want to know, because this is the terms that a textbook would use. And the two that come in time and time again are on the top of page 34, right behind this. What is an angle of elevation? What is an angle of depression? Think of it this way. Angle of elevation. You're looking straight, and you're turning an angle up. Angle of elevation. Angle of depression, the opposite. You're looking here and I'm turning down. And you're going to see this terminology used in almost every textbook. So, number one, let's do a problem and see how we're going to solve it. Angle of elevation 100 feet from the base of a tall building to its top is 80 degrees. How tall is the building? Would this be useful out in the field if you were doing a tech sketch of a building? Yeah, you bet it would. Don't need it. I don't have many tapes I can stand there and get 80 feet in the air, or whatever this thing's going to turn out to be, multiple floors. I can buy a $10 clinometer, measure the angle, pace off some distance, and I can get down to within a foot or two of exactly how tall this thing is. So, first thing we want to do is analyze the problem for the information. So I have a format I am going to look at next, and I would like you to follow this format for all of the homework you do. It's on the next page. I do this problem on the next page. So let's go through this. This is the way I expect your homework to be in this format. Remember, the first day I made a big point. These things need to be neat. I'm not hunting through a bunch of chicken scratches for stuff. Because we've got to make them ready for the workforce. So follow this format. We call it the engineering format of problem solving. Every person that works in the engineering field has probably been trained in this method of solving analysis. Think of it like you're drawing outlines. That's exactly what it is. It's an outline for a math problem. First thing you do is you have a given section. Here is where you state all of your known information. I like sketches, hence that's why I like drafting. So I do a little drawing. Okay, I know that I've got some building, don't know how high it is. I forgot to put flames. I was going to put flames in one of those windows, so he had a reason for yelling how, or she did. We know that the angle of elevation, we can assume the ground's flat. We know we're looking up 80 degrees and we're looking towards the top of the building. Can we assume that this building is built straight up and down?
Probably.
I think so.
Pretty close.
Yeah, unless we're looking at the Leaning Tower of Pisa. Okay, we're straight up and down on buildings. That's the goal. So we know that that is a 90-degree angle. That's always the first thing you look at when you triangle. Do I have 90 degrees? Because if I don't have 90 degrees somewhere, I can't use a Pythagorean theorem and I can't use SOHCAHTOA. Got to be 90 somewhere. Next thing I know, I'm 100 feet from here. So this is your given section. State your knowns, however you wish to do it. Some people will do it in text. Some people will do it in sketches. Most times I have two sketches in my given. I do one that's kind of like this, where I'm trying to replay the whole scene in my mind. And then I'll do an immediate sketch off to the side where I get rid of all of my abstract stuff, because it's really just a triangle. This case, I put it right down here. Now, once you have a given section, then, and that's usually on the left side of your page so somebody can find that. You're going to then have a find section. What are we going to put in the find section?
The height of the building.
What are you trying to do this math equation for? So what are we looking for? Again, that's basically going to tell us the journey we need to take, isn't it? The given is my start, the find is my end. That's what I'm doing with those two sections. Now you can do something like this, or you can redraw the triangle and say, hey, I'm looking for side x or the hypotenuse or whatever you want to call it. Now, after that, you come to the solution part. Think of this as your journey that you're going to take to get from given to find. The solution part is your journey. Here you are going to solve the equation. Okay, so here's our triangle. One thing I didn't do in this example that I should have is this side right here, you might want to make these changes in the text. There's your opposite, there's your hypotenuse, there's your adjacent. Any questions on how I got those labels? Okay? So what I'm going to do here, and this is a fail-safe to use the equation. Let me just show you this. We go tangent of some angle is equal to opposite over adjacent. Cosine of some angle is equal to the adjacent over the hypotenuse. Sine of some angle is equal to my opposite divided by my hypotenuse. Write all three equations down on a piece of paper. How do I know which one to use? Go to this and say, what do you know? Okay. Do I know the angle? Okay, I know that. Okay. So I'm going to come in here and I'm going to do a square around everything I know in all these equations. I know that. What else do I know? I know the adjacent side, right? So I come in here and I make a square around all my adjacents. Next thing I do is what am I looking for? Okay? In this case, I'm looking for the height of the building, which is my opposite side. Right? So I'll come in here and I usually use a different symbol for this. So I make a revision cloud around that one. Which equation has all three terms accounted for? Generally, that's the one you're using. Okay? Because these all have three variables. 1, 2, 3. 1, 2, 3. 1, 2, 3. I got to know two of those three to use an equation and solve for a real answer. That's the only one everything's taken account of. Almost all textbooks, all story problems will be given in such a fashion that only one of these will be right. If you have two of them that have all of those terms, you can use either one. In this case, we're using tangent. So here's your numbers. Again, you might want to make this change. What we're really doing here is opposite over adjacent. This is the algebra, so I'm isolating my opposite side here. So I have to take 100, got to multiply both sides by it. If you plug this into your calculators, 100 times the tangent of 80, you should get 567.13. Please check that and see that you do. You good, Declan? Are you not done yet?
Yeah, I got it.
Okay. Did you get it, Lisa? Okay, with your calculator, you're going to have 100 times, hit your tangent key, hit 80,
Yes,
okay?
sometimes I have to attend the first and the second.
Okay. Now, with this format of problem solving, when you get your answer, it needs to be double underlined. And you bring an arrow from the right side of the page pointing out where it's at.
That's the answer, is you double underline?
Yep. So it'll look just like this. You're going to have a given section, you're going to have a find section, you're going to have a solution section. Try and stay in an orderly fashion. Some people will go left to right, some go top down. I don't really care. Whatever works best for your mind. When you get to the answer, I do expect it to be double underlined, and I expect an arrow to come clear from the right side to wherever it's located and point out where it's at. If you want partial credit for your problems, follow this format. And in fact, to be honest with you, if you don't give me this format, I'm not even going to take your homework. I'll just hand it back to you and say, please redo it. But this makes everybody's life easier, and what we're trying to do is get ready for the workforce, right? You're sharing this with peers that sit in the next grade. We all do them the same. We can figure this out. First thing we do is we look right here for that arrow. Oh, there's the answer. And then we can figure out everything else that goes along with it. If it's not the right answer, we come up into the given. Was there a bad assumption here? Did they not really understand what you're looking for, so we didn't analyze the problem correctly? Makes fixing these things easy for anybody. If you like going on vacation and not getting called by work, follow this. Because we don't need your input. Are we clear on that? All right, we're about out of time, so I got a couple handouts for you. I wish we had time to work one more problem, but we don't. We'll do them next week. You're in this, right?
Did you hear me?
Uh-huh.
You want it anyway?
Just like your,
Okay.
Sorry.
We'll choose a very efficient line here.
Is it all the ones that have like this?
Okay. First off, the A sheets. This is your homework. It is due in 2 weeks. It's not due next week, it's due in 2 weeks. Next week we are going to run a lab where we're going to come in, we're going to do a little bit of work right off the bat. Pop quiz. We're going to work a couple of problems so you see some more examples, and weather permitting, if it's freezing cold outside, we'll bag it. Well, but if it's not, we're going to head out and do some stuff outside and put Trig in action. If not, we'll try and find something around the room we can put it in action with. So how would we use this to find information? Only do the problems that have a number next to them that are signed. So there's 10 of them. So on the first sheet is number 1. Goes with the figure on the next page. On the next page you have 2 through 7. The next page is 8 and 9. And you have 10 on the last page. 10 is my favorite one because you have to think outside the box a little bit on that character. Now, as we come into this, I will check your setup or your find section on any of these that you want me to. Please take a stab at doing it yourself, deciphering the information out of the story problem, and then get your sketches. If you have no idea if you're right or wrong, bring them to me and we'll go through them and go over it. Because learning how to read a story problem and get the right information out of it is a skill when we need to adapt. So, those 10, please. 2 weeks. I gave you one other little handout. And where's your copy of it? This little thing right here, the baseball problem. Is everybody familiar with baseball? We call it a diamond, but it's a square tilted 45 degrees. If you do this problem, it's extra credit, and I'll give you 50 percentage points on any assignment through the year if you get it right. You have to use a right triangle, though. You can solve this with oblique triangles, but I want you to use a right triangle. This is due next week if you wish to get the extra credit for it. This is a great problem. It will cause you to think. You will need some diagrams. And if you can solve this, then you can adapt what you're doing in the workforce to Trig. So this is worth 50 percentage points to anything you do all year except for the final. Yeah, I'm not going to apply it to the final.
Where's the shortstop?
Shortstop plays in between second and third base.
Yes, if you've never seen
Anyway, I just want to make sure I know.
baseball, then
I know it.
so we got home here. This is first. This is second. This is third. And the shortstop plays kind of right here in the middle. It's a square, and you're given the length of the sides, right? Distance from home to first, I think is what they do. What do they give us here?
Yep.
60 feet. Oh, this is ladies fast pitch softball. One of the greatest games I've ever come across. I like it much better than baseball. Hey. We're going to stop there. Like I said, next